So we're going to talk about independent and dependent events. And now at the very beginning, I talked about events that happen at the same time, which we just did, but they sometimes have something in common. Here, independent and dependent events are events where they either don't have any correlation to each other, don't depend on each other, or where one affects the other. And a dependent event, obviously, you have one that affects the others. They're related to each other. So with a dependent event, the occurrence of one event affects the other, and these are sequential. So let's talk about an independent event. So the independent event, we're going to have a paper bag. Let me see, what color do I want to make my paper bag? I'll make it blue. So I have a bag of marbles, and in that bag I have, I have 1, 2, 3, 4 green marbles. So let me put them in the bag. And actually I should draw my bag properly. So I have 1, 2, 3, 4 green marbles, and I have 2 red marbles, and I have 1 blue marble. Okay, and so we're going to consider what is the probability of choosing a green marble and then a blue marble from this bag. Okay, so what is the probability of choosing green and blue? Okay, so probability of choosing a green marble and then a blue marble. And in the first situation, after picking the first marble, you're going to put the marble back in the bag and pick again. So the first one is an independent event. This is going to be independent because you're going to do this first. You're going to pick from the bag and you're going to put it back in, because we're doing it with replacement. In other words, we're putting the marble back in the bag. And it's independent because the number of marbles in the bag is not going to change because we're going to put it back in, right? So when I pick from the bag the second time, it'll be the same number to pick from that there was the first time. Okay, so first I'm going to pick green. So when I pick green, I can pick 4 out of 7, right? I have 4 chances to get it. And then out of 7. But because I put it back in, because I put that same marble back in, I pick the green and I put it back in, I still have the same amount of green to pick from the second time, the same amount of blue, and the same amount of red. So when I pick, and my chances of picking green the first time, I have 4 greens, so 4 chances out of 7, right? And the second time, I have 1 chance out of 7 to pick, right? But what is different about this is that these are multiplied. They're not added. Okay, so the first time you pick, you have 4 out of 7. The second time you pick, you have 1 out of 7. So your combined chances is going to be 4 out of 49. Okay, so that's if you do it with replacement. And that's an independent event. Well, let's look at dependent events, okay? And I'm gonna maybe just put a line here to give ourselves some space so I can draw a dependent event. And this is without replacement. Okay, in this situation, I have my bag, my first bag. And I'm still starting with the same amount of green marbles. I have 1, 2, 3, 4 green marbles, and I have my 2 red marbles, and I have my 1 blue marble. Okay, and I want to pick green and blue. What's the probability of green and blue? Same thing, P, green and blue, but the only difference is that I'm going to not replace that marble. So when I first do green, and I should have said green and blue because the second is blue, so let me make sure I rewrite that. When I pick the green marble, and then later the blue one, then when I first pick the green, same thing as before. I pick 4 out of 7. But I don't put the marble back in. I keep it out. And actually, I'm just gonna show that green marble ends up here, but does not go back in. So when I go back in the second time to reach into my bag, my bag is not as pretty as it was at the beginning. It's getting crumpled. I only have 3 marbles that are green, but I still have my 2 reds, and I still have my 1 blue. But my total number of marbles has changed, right? So when I go in to get my blue, I still have the 1 blue to pick from, but it's 1, 2, 3, 4, 5, 6. I only have 6 in the bag total. And so my probability has shifted to 4 out of 42, which then reduces to 2 out of 21. So these probabilities are worded slightly differently. The probability of A and B, when you have an independent events that none of them depend on each other, right? Because you're starting with the same bag, same amount in both times, is just the probability of A times the probability of B, okay? But when you have one event depending on the other, first event changed what you could do with the other. We call this the probability of A and B. With dependent events is called the probability of A times the probability of B, and we call that given A. In other words, given that A has already happened, right, the probability of B is going to be different, okay? So that is what happens with independent and dependent events, okay? And let's see how I am on time. Let's see. Let's try number 3 in guided practice, and then I'll do the final problem. So these ones will go right all the way through. All right. So if I'm looking at guided practice 3, a marble contains 4 red, 5 green, and 2 blue marbles. So I won't draw the bag this time. This is guided practice 3. So I have 4 red. I have 5 green. And I have 2 blue marbles. Okay, so I have 4 plus 5 plus 2. Right, so I have a total of 11 marbles. Okay, and this is in my bag. You randomly draw 2 marbles one at a time. Okay, find the probability that both are red. So I want to find out what the probability, my probability of both are, so of red and red. If I replace, so this is if I replace the first marble. Well, in that case, I have independent events, right? I'm replacing it. So probability of red the first time is going to be, I have 4 reds out of 11. And I'm replacing that red. So the second time, I also have a probability of 4 out of 11. So I have 16 out of 121. Part B, they're going to say again, what's the probability of red and red if I don't replace the first marble, right? If do not replace the first marble. Well, in that case, your first probability is still 4 out of 11, but now I only have 10 left in the bag after I keep my first red one out. So, and I've taken out a red marble, right? So I've taken out a red marble, and so the second time around, how many reds are left? Well, there's 3 reds left, but there's also only 10 marbles left, right? Because I've taken out the red, so I have 3 left of the red, but I also have taken out a marble, so total I have 10. So I end up with 12 over 110. And of course, if I reduce, I will end up with 6 over 55. Okay, so that is guided practice number 3. And I have one couple of more problems to do, and we're going to end this lesson.